Definition. We shall begin our session by defining soil. Soil may be defined as a naturally occurring thin layer of unconsolidated particles covering the Earth's surface. Soil provides a foundation for plant and animal life on land. Soil composition. Soil consists of 5 main components. These are inorganic components and mineral particles, organic matter or humus, water or moisture, air or gases, and living organisms. Inorganic components and mineral particles. These make up about 45% of the soil. They are derived from weathering of parent rocks. The size of the mineral particles determine the texture of soil and the physical and chemical characteristics. Organic matter. This forms about 5% of the soil. It is derived from decaying plants and animals and their wastes. These are broken down by fungi and bacteria. Organic matter gives soil a black or brown color. It binds soil particles together. Soil water or moisture. Soil water forms 25% of the soil. It is held in the pores and contains dissolved minerals and salts used by plants to grow. Soil air. In the absence of soil water, the soil pores hold air. Soils with large pore spaces hold much air, while those with small pore spaces hold less air. Soil air is essential for plant growth and for survival of useful living organisms in the soil. Living organisms. Living organisms contained in soil include worms, insects, bacteria, and fungi. These organisms help to break down the inorganic particles to produce soil. They also contribute to fixation of nitrogen from the air. There are 3 main soil-forming processes. These are weathering, decomposition of organic matter, and leaching processes. Properties and characteristics of soil. Properties of soil refer to its physical and chemical characteristics, which include the following: soil structure, soil texture, soil color, soil porosity and permeability, and soil pH. Soil structure. Soil structure is the arrangement of soil particles into groups or aggregates and shapes. Soil particles are held together to form clusters. There are 6 types of soil structure: crumbly, granular, platy, blocky, prismatic, and columnar. Crumbly. Crumbly soils have particles that occur separately. They are loose soils, porous and well aerated. Granular. Granular soil is made up of rounded aggregates of irregular shape. The particles are small and loose. They hold a lot of water. Platy. In platy soil, the soil aggregates are arranged horizontally or as flat plates. The plates overlap and so impair air movement and permeability. Blocky structure. In blocky structure, the aggregates are arranged in rectangular blocks that easily fit together. They are well drained and well aerated. Prismatic. In prismatic structure, the aggregates are arranged in vertical cylindrical columns that vary in length. These soils are permeable. Columnar. In columnar structure, the aggregates form column-like structures formed due to the accumulation of sodium. Soil texture. Soil texture can be defined as the degree of fineness or coarseness of minerals matter in the soil. Soil particles can be grouped according to their sizes, that is, coarse texture, for example, stones and pebbles. Medium soil color. Soils have different color. Soil color is influenced by the type of parent material chemical composition, content of organic matter, and drainage of the area in which the soil is found. Soil porosity and permeability. Porosity refers to the amount of pore spaces in a given soil. It measures the ability of a soil to take in or hold water. Soils with many pores hold a lot of water, while those with few pores do not allow water in. Soil pH. Soils contain three chemical properties. These are acidity, alkalinity, and neutrality. The measure of soil acidity and alkalinity is referred to as soil pH. The degree of acidity or alkalinity is expressed in the pH value ranging from 1 to 14. Soil classification and soil types. Soil changes indefinitely from place to place. To facilitate the study of soils, certain systems of soil classification are used. Some of the methods used include using soil properties and content, using genetic system that is based on the characteristics of the soil, and using soil orders that combine soil-forming factors, their basic properties, and zonal systems under which they occur. In this session, you will only cover the classification of soil according to soil orders. This classification system is based on three main divisions, namely zonal, azonal, and intrazonal. Zonal order. These are soils that develop under natural environmental conditions. They are mature and with well-developed profile. They tend to correspond to the world climatic zones. Tundra soils. Tundra soils occur in cold areas. These are the higher latitude and high altitude areas. Podzols. Podzols occur in temperate regions. These are the mid-latitude areas about 45 degrees to 60 degrees north. Pedocals. The soils occur in semi-arid and subhumid area. Here, we have extensive areas covered by grasslands. Latosols. The soils form in conditions of high rainfall and temperature. These conditions accelerate the rate of decay of organic materials and weathering of the parent rock. Xerozems or desert soils. The soil intrazonal order. The soils are of widespread occurrence. They form under varied conditions such as rapid evaporation, poor drainage, aridity, and dominant influence of parent rock. The soils are subdivided into the following groups: hydromorphic soils, halomorphic soils, calcimorphic soils, and andosols. Hydromorphic soils. The soils form under waterlogged conditions. This occurs in bogs, marshes, and mudflats. Due to waterlogging, the bacterial action is reduced due to deprivation of oxygen. Halomorphic soils. These are soils formed under semi-arid condition through salinization. The soil contain high levels of soluble salts, are saline, and are infertile. Calcimorphic soils. These are soils formed on limestone. The influence of limestone parent rock is often important more than the local climatic condition. Andosols. The soils form from recent volcanic materials. The soils are commonly known as the volcanic soils. The soils are fertile and well drained, however, they are prone to soil erosion. Azonal order. Azonal soils are also known as entisol. This means recently formed soils. The soils are usually thin and have no clear profile. Mountain soil. In areas of high mountains, such as Mount Kenya, Kilimanjaro, or the Atlas, the soil forming process are highly influenced by the mountain climate. They are also influenced by the altitude and the general configuration of the mountain. Hystosols. Hystosols are another type of azonal soils. They form from accumulation of materials in swampy areas. Arenosols. In semi-arid and coastal areas, the soils that occur are the arenosols. Alluvial soils. Alluvial soils are also known as fluvisols or luvisols. Their fertility depends on the nutrient content of the soil and the parent rock in the catchment areas. Aeolian soils. In deserts and semi-arid areas, aeolian soils occur. They form from the wind deposits. At times, the deposition is far from the confines of the deserts. The deposited soil is known as loess. Soil profile and soil catena. Welcome. Soil profile. A soil profile is the vertical arrangement of different layers of soils from the surface of the bedrock. These soils layers are called horizons. A typical mature soil profile has 4 horizons, namely Horizon A, Horizon B, Horizon C, and Horizon D. Together, all these horizons make up a soil profile. Soil catena. This is the sequence of soils along a slope. It may also be defined as the arrangement of soil on a mountain slope from top to bottom. The plateau. In this part of the slope, the soils are leached, thin, and have a laterite cape. Soil degeneration. Soil degeneration refers to a process by which soil loses fertility. Soil degeneration may also be referred to as soil degradation or soil deterioration. Soil degenerates when it loses its mineral contents, when it is eroded, or poorly used or overused. Types of soil degeneration. There are 3 types of soil degeneration, namely physical degeneration, chemical degeneration, and biological degeneration. Let us now explain the above types of degeneration. Physical degeneration. This refers to the decline in the usefulness of soil in which soil structure, texture, moisture, and quantity are affected by factors such as poor cultivation, overgrazing, heavy rainfall and drought. Poor cultivation practices like shifting cultivation leads to clearing and burning of vegetation, thus leaving the ground bare. Overcultivation causes soil to become very loose and fine, thus making it prone to erosion by running water or by wind. Overcultivation also causes exhaustion. Overgrazing causes soil to become loose and fine-grained, thus affecting soil texture, structure, and moisture content. Large herds of livestock trample on the ground, thereby breaking the soil. Too much rain may change a cramped soil structure into blocky or columnar structure. Drought may alter soil structure and texture. For example, when soil dries, its particles break, thus becoming loose and finer and prone to erosion. Chemical degeneration. This is the deterioration of soil due to change in soil pH and mineral nutrients. Biological degeneration. This is the decline of vegetation cover and organic content of the soil. Human activities such as overgrazing and cutting of trees lead to reduction of vegetation cover. Soil erosion. Soil erosion is the removal of topsoil by agents such as moving water, glaciers, and wind. Causes of soil erosion. Soil erosion can occur naturally but can also be caused by human activities. Natural factors that may cause soil erosion include strong winds, steep gradient, and climatic conditions. Causes of strong winds. Strong winds in dry areas blow away loose soil particles, leaving the surface with little or no soil. Steep gradients. Steep slopes may accelerate soil erosion. Steepness of land encourages surface runoff. The water moves at high velocity and has a lot of erosion power. Climatic conditions. Arid condition and erratic rainfall can cause soil erosion. Erratic heavy rainfall causes splash, reel, and sheet erosion. Human activities. Human activities that cause soil erosion include clearing of vegetation cover, overstocking, poor methods of cultivation, and excavation works. Types of soil erosion. There are 4 types of soil erosion, namely splash erosion, sheet erosion, reel erosion, and gully erosion. Splash erosion. During heavy rainstorm, the rain drops, heat, and loosen the unconsolidated soil particles. This type of erosion is called splash erosion. Sheet erosion. This is the uniform removal of a thin sheet of exposed topsoil by rainwater washing downslope. The whole top layer of soil is removed gradually, real erosion. After the rains, the water begins to concentrate into small streamlets, though not clearly defined as channels. The small streams are known as rills, which cause rill erosion, gully erosion. This is the uneven removal of surface soil of steep slopes. Rainwater flows tiny channels called rills, thus widening them. The rills become bigger as they join one another. Wind erosion. This is removal and carrying of dry loose soil materials by the force of wind. Eddying winds remove unconsolidated soil particles from the surface and transport them by lifting. This leads to lowering of the surface. This process of lowering the surface is called deflation. Suspended soil particles may erode soil surfaces through abrasion. Wind erosion is most effective in arid and semi-arid areas where rainfall is low and unreliable. Such areas are bare and therefore soil are exposed and unprotected, making them prone to erosion. Management and conservation of soils. Soil is a renewable source which can be replenished or renewed. Soils need to be properly managed and conserved to avoid and prevent their degeneration for sustained productivity. Soil management measures. The following are soil management measures. Testing the soil pH. It should be tested to establish the acidity level and lime added to facilitate crop and pasture growth. Saline soils. These can be regularly flushed with plenty of fresh water to leach the salt and soils to become neutral. Alkaline or sodic soils. Gypsum is added and fresh water flushed to leach sodium. Regular addition of animal and plant manure. Limited chemical fertilizers under supervision can enhance fertility. Preventing floods by construction of river embankments and levees. Returning crop residual to the farm to improve the soil texture and prevent lumping. Educate farmers to increase their awareness about soil degeneration and preventive measures. Soil conservation measures. These are afforestation and reforestation. Terracing. Terracing involves shaping the land to create horizontal steps that are made on steep slopes. Strip cropping. This involves planting different types of crops in alternating parallel strips along the contours. Planting cover crops. This is where crops are grown to cover the soil properly, such as sweet potatoes vines, to protect the soil from agents of erosion. Contour plowing. This is plowing along the contour that is across the slope rather than up and down the slope. Rills and gullies are therefore less likely to develop. Crop rotation. This is a practice in which crops which require different nutrients are grown on the same piece of land on a rotational basis. This prevents exhaustion of particular mineral nutrients from the soil. Regulation of stock numbers. This is keeping the number of livestock that the land can comfortably support without destroying it. This can be done by reducing numbers or by creating paddocks. Building gabions. Gabions are wire mesh structure filled with stones to trap soil and allow water to pass through. Mulching. Mulch is a general term for protective ground cover which include chips, straw seaweeds, leaves, and other natural products. This is the use of plant remains to cover cultivated ground. Soil is conserved through the following ways. Reducing evaporation of water from the soil, protects the soil from erosion, increase the humus content of the soil, increase the rate of infiltration of water into the soil, and providing suitable habitat for burrowing animals which shun the soil and increases its permeability.